Good morning, class. Mr. This is here in another one. I'm very excited, energized to come back in equation of circle, property of circle, guys. Remember, this is one of the properties that has a lot of concept. So you will have a lot of concept throwing at you. So you need to have your head above your shoulder. Remember your concept, remember your theorem, or otherwise the properties of circle gonna play trick on you. So you need to be on your game, play steady, so you can remember those theorems. Because property of circle has too many theorems to remember. The only way you're going to remember them is by practicing. Oh, why? Remember last class we went over definition of line of tangents. When you have a tangent, a line that the tangent is a circle, is a line that only touch the circle only at one particular point, and that point is called the point of tangency. Today we're gonna explore, we're gonna expand to that knowledge that you have acquired about tangent line. So remember, if you line this tangent, it only touches the circle only once, and at the point where it touches the circle is called the point of tangency. Today what we are going to do, we're going to find the center of the circle. Alright? Now we have this circle C. Any circle is named by its center. So we have circle C, which is the center is C. If you take the point of the center and you connect it to the point of tangency, which is point B, then BC will be perpendicular to the tangent line. Always sure. So that's telling you your goal is to identify your tangent line, and where the point of tangency is, if you join that to the center of the circle, those segment, the radius will be perpendicular to the tangent. Meaning perpendicular means at the point of the intersection they will form 90 degrees. This angle will be 90 degrees and this angle will be 90 degrees. As you know already, it's a line. Alright? A straight angle. A line is a straight angle. The two angles that form the line, that will be linear pair, will add up to 180. So this telling you again, let's stress this out. If you take the point of tangency, you connect it to the center of the circle, the radius will be perpendicular to the tangent line, meaning that there's a 90 degree that will be formed at the intersection. This is a very easy concept to remember, that you have your tangent line, and you take the point of tangency, you connect it to the center of the circle, the radius will be perpendicular to the line of tangent. That's good. Let's try to remember that. Any line that is perpendicular will form 90 degrees. That's the first concept. The second concept is that circumscribed angle. A circumscribed angle is an angle that is outside of the circle. So a circumscribed angle of a circle and its associated central angle are supplementary. So let's find out what a central angle is. Now we have learned that a circumscribed angle is an angle that is outside of the circle. In this case, angle Z is a circumscribed angle. Right? Circumscribed means outside. So we're going to learn what the central angle is. A central angle is an angle that is in the center of the circle. Is an angle that is formed at least with two radii. So in this case, if I need to find a central angle, I have my center of the circle, which is point X, so I can connect point W, which is the point of tangency, to that. As you learned earlier, that any point from the center of the circle to the point of the tangency will be 90 degrees. Therefore, this will be a 90 degree angle. If you do the same thing from the point X, right, the center of the circle, you join it to point Y, which is the point of tangency, that also another radius that will be perpendicular to that tangent. Now your central angle is an angle that formed between two radii. See, this is, you have a radius wx and you have a radius yx. Remember, all radius of a circle are congruent. And we know from prior knowledge, these tangents are congruent. Now, if you recall that you will have a kite. A kite is a quadrilateral that add up to 360 degrees. So your central angle, which is angle x, this angle here, and angle z will be supplementary. That's what this lesson is trying to convey to you. Let's go back again. A circumscribed angle and its of a circle and its associated central angle are supplementary. This circumscribed angle z and the central angle x will always be supplementary. And in addition that, if we have that radius that is perpendicular to that tangent, and we have that radius that is perpendicular to that tangent, and remember also, if you have a central angle, the central angle will be congruent with its intercepted arc. Therefore, if this is x degrees, this will be x degrees. Alright? Central angle and intercepted arc are congruent. Likewise, if angle x plus angle z are supplementary according to this definition, so you will have measure of angle x plus measure of angle z, which is the circumscribed angle, are supplementary. In this case, we can have the same thing. The intercepted arc, which is the measure of W y, right? That's the arc, plus angle z will also be supplementary. That's what this theorem is trying to convey to you. So let's recap that the first definition, that if you have a tangent line and you take the point of tangency, you draw it to the center of the circle, the radius of the circle will be perpendicular to the tangent line. Alright? Tangent line that connect the point of that join to the point of tangency to the center of a radius are perpendicular. Right? That's mean at the intersection they will form 90-degree angle. That's the first theorem. The second theorem says that if you have a circumscribed angle and its associated central angle, they are supplementary. In this instance, angle z plus angle x, which is the central angle, will always be supplementary. And as you see that two tangents are congruent from prior lesson, WZ is congruent to ZY, and XW is congruent to XY, and this quadrilateral will be a kite. So the four angle will add up to 360 degrees. Meaning that if I take measure of angle Z plus measure of angle W plus measure of angle X plus measure of angle Y, this will be equal to 360 degrees. Remember, a kite is a quadrilateral. This is the lesson that we're going to practice today. I'm going to take a time out, then we're going to come and do some application. We resume our lesson on how to solve the angle of a circumscribed angle and its associated central angle in the property of a circle. So in this case, we have this lesson where they're asking you to find measure of angle J and measure of angle KML, which is the central angle. As we discovered earlier, that the circumscribed angle, angle J, is supplementary to its associated central angle. Its central angle in this case, it's MKML. So there are two ways we can do this lesson. So angle J and this central angle M and this angle are supplementary. Alright? And remember that earlier JK, which is a tangent, is congruent to JL. Those two tangents are congruent. They share the same external point. And as you can see, KM is a radius. Therefore, all radius on the same circle are congruent. In this case, we have a quadrilateral, which is a kite, that sum up to the four interior angles sum up to 360. As you can see that we have the point of tangency K. If we join that to point M, this is perpendicular to the tangent. This will be a 90-degree angle. And likewise, if we draw the radius from point M, the center, to the point of tangency L, which is the tangent line, will be perpendicular. You will know that major of angle J plus major of angle K plus major of angle KML plus major of angle L will be equal to 360 because it's a kite. The four interior angle will be supplementary. So we're not interested in this. So let we use the circumscribed angle, which is angle J, which is represented by X. So we can have X plus its associated central angle, which is angle KML plus 3X. That will be supplementary. So this is the one that we are going to solve for X. So the circumscribed angle and its associated central angle are supplementary. That's what the property told you earlier. So in this case, you will have 4x, right? 3x plus 1x is 4x. You will have 4x is equal to 180. You divide by 4, right? In this case, you will find the value of x. In this case, x is about 45 degrees. Now we can find the major of angle J. In this case, major of angle J will be 45 degrees. That was not known. Now we know it now. X is 45 degrees. And to find the major of angle KML, we see the central angle represented by 3x. That will be 3 times 45. In this case, that will give you 3 times 5 is 15. You carry 1. 3 times 4 is 12. 12 plus 1 is 13. That will give you 135 degrees. This central angle will be 135 degrees. Now, to recall that this is 90, perpendicular, and you can see that the four angle will add up to 360. And recall that if you know the central angle, which is 135, and also its intercepted arc will also be 135. This also will be 135 degrees. Therefore, you will be able to know how much this other arc is. So that's going to come in another lesson. That will be 360 minus 135. That will tell you how much this arc is. This is how powerful that math is. Then you subtract from there. That will give you 2. Therefore, this other part of the circle will be 235 degrees. 225 degrees. Right? Next question. Again, we have the same situation. We have center C. If we join it to angle A, which is the point of the tangency, this will form a 90 degree. This is the radius, and the other radius is CB. If we join it to the point of tangency, that will give you perpendicular, that will give you 90 degrees. So the radius CA is congruent to radius CB. That always true. The radius of the same circle are congruent. And we know that AD is a tangent and DB is a tangent. Therefore, those two tangents are congruent. From prior knowledge, in this case, we're dealing with kite. So since those four angles should be added up to 360, we already have 180. If we subtract 180 from 360, there are 180 degrees left. Therefore, those two angles will be supplementary. Alright? Then we're going to write the equation to solve for that property. So we'll find the other two angles. So remember the lesson telling you the circumscribed angle and its associated central angle are supplementary. Supplementary means two angles that add up to 180. Then you will have 5y plus 4 plus 15y plus 16 is equal to 180. That's our equation. Now we need to combine like term. 5y plus 15y is 20y. 4 plus 16 is 20 is equal to 180. As you can see, those have 10 in common. You could have divide and simplify that. So some of you will not do that. So we'll have 20y is equal to 160. Then you divide by 20. And those 0 cancel each other. Then you have y is equal to 8 degrees. Y is 8 degrees. Remember, this is your partial answer. This will guide you to find your final answer or your total answer. Now, since I know y is 8 degrees, I can find measure of angle D. For measure of angle D, which is 5 times 8 plus 4. And measure of angle D will be, right, 5 times 8 is 40, and you will have 40 plus 4 is 44. Measure of angle D is 44 degrees. Now we know what measure of angle D is at this time. Measure of angle D is 44. Now to find measure of angle C, if you do everything correct, you can subtract 44 degrees from 180. You will get about 136 for angles, the central angle, which is represented by 5y plus 16. The alternative, you can go and substitute it for its value, where we can find measure of angle ACB, which is 15 times 8 plus 16. Alright. Then you will have to find measure of angle ACB. Then 8 times 5 is 40. You carry 4. 8 times 1 is 8. 8 plus 4 is 12. That is 120 plus 16. Then in this case, you will find measure of ACB, which is the central angle, which is 136 degrees, which we predicted earlier. This angle will be 136 degrees. Now, since you know the central angle, and you can always find the measure of the intercepted arc for the central angle, which is arc AB. In this case, measure of arc AB will also be 136 degrees. Now, if you want to find the remainder portion of the circle, you will take 360 minus 136. That will tell you how much the other axis is. In this case, you will have 360 minus 136. That will give you 4. That's 2. And that will give you about 224 degrees. This will be 224 degrees. So that was our lesson, how to deal with the circumscribed angle and its associated central angle. Both circumscribed angle and the associated central angle are supplementary, meaning they will add up to 180. So if you don't recall that theorem, you can always make the plane of tangency to the circle a 90-degree angle, and you will have two 90-degree angles. Since this is a kite, the sum of the four angles in the kite as a quadrilateral should add up to 360. You can add the four angles and add up it, make it equal to 360, then you solve your equation. That was steady C's, steady, and drill. You're going to make the grade. See you in another one.